There's been talk a lot of, obviously not just drones, but drone swarms, dozens, hundreds, thousands of AI-enabled, battle-networked, drones, attritable units acting in coordination. We're trying to build versions of these, obviously, in different companies. What makes HPM a viable solution against the swarms? Like, you can turn off all of them at once?
Well, that's the thing. It's a wider area effect technology. So where you have lasers, you think of a laser has a very, very tiny little beam that needs to hit one target at a time and burn through that target and then disrupt it. A microwave system, especially at the frequencies we're using, can be very broad and spread. So we can spread all of that microwave into the atmosphere, and everything in that section of the atmosphere would be affected by that electromagnetic radiation. So it lends itself, just by the sheer nature of what we've brought to kind of the Army and then the DoD at large, just the sheer nature of it allows for that combating of a parallel set of threats. And when you combine that with some of the big data techniques that you see in automatic driving and other types of industries like that, you have a sensor system that can see hundreds or thousands of things at the same time, AI that can drive basically an effector that can very quickly determine, okay, here are these drones, 100 drones coming from this direction, hit them with a wall of these frequencies and these waves. Here's another set of drones coming from this direction. Next, shoot the beam over there in a microsecond and put another wall on top of those.
Is that system ready? Have you tested that system that's looking at what's going on in a battle and helping make those decisions?
The system now is in its infancy, but those hooks and those basically that fully automated mode is dialed into the way we architected it. So today the military is not willing to go fully automatic, and there's a whole bunch of discussion we can have around ethical AI and if we're really ready for the robots, so to speak, to start taking over our machines. And in the case of this type of warfare, it's going to be necessary. The necessary decision to go forward with AI controlled battle. Otherwise, a man or a human in the loop won't work.
Yeah, if I have thousands of things coming at me controlled by AI that are dynamic, that are fast, that are hitting me from multiple directions, I sure as hell hope that our shield we're putting up to fight them is also enabled by AI making the decision to put them all down once you tell them that. I think the framework is, of course, you have to agree that it's on a mode where it's going to be shooting things down, but then I think you obviously have to let it go and do it. Otherwise, you're going to be a lot slower if a person has to be pressing the button every time. It seems pretty obvious to me. I don't know if there's really ethical questions there. I guess some people think there are still, huh?
Well, when we were working on Next Generation Jammer, it was a similar issue where the jammer could go out automatically and hit a whole bunch of traditional targets like the integrated air defense systems that line up along the coast. They could hit multiple ones of those and they could calculate how to do it internally. But we fought for sort of an automated mode, and the military at least 10 years ago hadn't quite ingested enough sort of experience around AI to trust it fully. So if you look at even Next Generation Jammer today, I think it's run, and I haven't been on the program for 10 years, but how it was going, it was run as a program that had a man on the loop, not in the loop. So they weren't making a determination of every sequence or every order, but they would have a final check to say, all right, go ahead and do it. And I think we now today have sort of that mode that we're basically starting to get into, with the idea of taking the Army a little bit further as the swarms become more and more prevalent into a fully auto mode.
It's the only option. To tell us a little bit about, there's something called capes and limbs, capabilities and limitations testing. How many types of drones you guys shoot down? How many drones can Lee and I shoot down at once? And how far ahead are we of the competitors?
Well, the great thing about it, so we did some capability and limitation testing out in the desert in April. Just this last April. And that's what sort of prompted the military now to go send their systems overseas. So we had a flying sort of passing grade, I would say, my assessment. The Army isn't going to endorse this yet. It's not been released yet, the report. But from my assessment, we exceeded my expectations. We completely exceeded my expectations. They conducted the event to have a lot of threats that bridge the gambit of different types of classes of different things. And so they tried to get as many as they could that would be relevant and something that we would see overseas. If we were to go overseas, they wanted to have relevancy, and they wanted even to have drones that might have been hardened or protected against electromagnetic emissions to see if they could get a militarized drone and send it into our system.
Yep.
Now, the first thing I'll say is we had 0 targets that we did not take down. In other words, we were 100% effective on every single scenario, and every single target that they threw at us, we had an effect on, which was incredible, which was just incredible. Now, we learned a lot as well, and we're in the process of rapidly fixing some of the things around the sensor integration and some of the other things that have less to do with how the high-powered microwave effector works and more about the support systems that are surrounding it that have to kind of map into the Army's overall structure, a larger air defense structure. So a lot of those systems, we found bugs and issues, things that are easy to fix that we're fixing right now. And we intend to be in deployment mode come this fall. So in this fall, we'll have a final sort of test out of all the different bugs that we learned in the first limitations test. And then we'll send these things overseas to really, really, really be in the war and out there on the front line with the warfighters. And so we're excited about that because we'll learn a lot and it'll give the world a chance to see one of our systems in action.
So knowing that these things are working so well and people are excited, you're building a lot more of them before they're even bought? Like, what are we building right now as a company?
Yeah, that's part of the Neoprime playbook. So we right now built ahead before we had anything on order. So when the Army gave us a contract, they said, see if we can deliver these in a couple years. It was 2.5 years, actually. We delivered 4 systems in 15 months. Mm-hmm. I mean, just unheard of. 15 months, 4 full systems to the Army. Now they're looking at sort of things that could improve the lethality, the range. You talked about wanting to reach out to miles. Yes, absolutely, we can do that. And so now we're basically rapidly on our own money, on money that we are self-investing in. We're building basically systems that I call it at a zero, compared to our baseline system. Everything that we can shoot at, let's say 100 yards, we could shoot at 1,000 yards with the system that we're building now. So a lot of work is going into that system because we think that system's going to be effective against the longer range targets. Still in the short range air picture, but when we're talking the long range, short range, we're talking 10 kilometers, 5-6 miles and that type of a range. And we're confident that we can build HPM that can have effects, very, very ubiquitous effects out at those ranges as well. Very, very confident. So it's very exciting right now.